Okay, so radian measure and arc length. So degrees versus radians. 1 radian is the measure of the central angle, theta. Okay, so central angle, and then this little guy is just theta. That's how we mark the angle. The intercepts an arc S equal in length to the radius R of the circle. Okay, so all that means is, okay, if here's theta, this represents your central angle. Okay, your radius is here. What's wrong? Oh, because the name. And then this is going to be equal to the radius. Okay. This little guy right here, it just represents the angle. It's the same thing as if I were to put like X there. Okay. Who remembers how we find circumference? From way back. Circumference of a circle. So you can have pi times diameter. What else could you have? 2 pi r. Very good. Pi r squared is area. Okay. And both of these tell us the distance all the way around. Okay, so both of those tell us the distance all the way around. Okay, so the mathematician, whoever it was, that created radians, okay, thought of just if the radius was 1. Okay, so if the radius is 1, okay, what would be the circumference of my circle?
8.
If the radius is 1, so I'm substituting 1 in here, what is my circumference?
2 pi.
2 pi. Okay, so 2 pi is what we are going to use as the distance around a circle completely. Okay, so 2 pi. How many degrees are in a circle? 360 degrees. So 2 pi is what happens when you go 360 degrees around a circle. So what do you think is going to be the circumference if I only go 180 degrees? Pi. What do you think is going to be the circumference if I only go 90 degrees? Pi over 2. What do you think the circumference is going to be once I go 270 degrees? 1.5, which is what? That was a fraction.
Is that pi over 2?
Mm-hmm. Okay. What is 1.5 as a fraction? 3 over 2. So you have 3 pi over 2. And this is 270 degrees. What other degree could I have here?
That's just pi. 180.
Yeah. What other degree could I have here? 0. Okay, so it could be your starting point or your finishing point. Okay, so 0 degrees and 360 degrees fall right there. Okay, let's pretend this is halfway. What degree would this meet at? 45 degrees. Okay, so in radians, okay, so anything that's in terms of pi is in radians. So this is 0, because that's where we're going to start. 0 to pi over 2. What would 45 degrees represent? Pi over 4. So if this is 0.5, half of that is going to be 0.25, which is 1/4. Okay. Now let's look at what happens if I drop this angle. So now we're looking from here to here. How many degrees would this be? 135. How'd you get 135? 90 plus 45. So every single time you're moving, you're adding 45. So 0, 45, 45 plus 45 is 90. 90 plus 45 is 135. 135 plus 45 is 180. Okay, so now let's look at it in terms of radians. Okay, if this is 0, this is pi over 4. This would have been 2 pi over 4, but we reduced it. What would this be? 3 pi over 4. Okay, so if this whole thing is pi, because it's just a semicircle, and we have 4 equal parts, it makes sense that it's going to be 0, then pi over 4, 2 pi over 4 reduced, 3 pi over 4, and then this would be 4 pi over 4, which is obviously just pi. And then when it comes to the degrees, you start at 0, and then add 45 each line you pass. So 0, 45, 90, 135, 180. So let's keep going. What would this one be then? Who's saying these? Is it you? How did I know? So 225 degrees, because it's just 180 plus 45. Okay, so this was 4 pi over 4, which simplified to just pi. What would this be? 5 pi over 4. Okay, if this is 225, we added 45 degrees to get to here, which is 270. 5 pi over 4, add pi over 4, and you get 6 pi over 4, and that reduces to 3 pi over 2, and then we have one more line to make. So you have 270 degrees here, so what's going to be here?
7 pi.
7 pi over 4, and then what degree matches that?
305? 315?
315. Okay, so this is just like an image, and I just basically wanted you to see that this arc length here would be, this measure is going to be pi over 4, pi over 2, 3 pi over 4, and it goes on and on. And then what we did, without even explaining to you guys what we did, we found the degrees given the radians, and the radians given the degrees. So we're going to work on now converting with numbers that are a little bit trickier. Okay, they're not perfect, however, they're easy to do. So, to convert between degrees and radians, okay, you have two formulas. Okay, degrees to radians, you take the degree given, multiply it by pi over 180. Okay, if you do it properly, when you go degrees to radians, your answer should have pi in it. Okay, because radians is always in terms of pi. Okay, if you're going from radians to degrees, you take your radian and you multiply it by 180 over pi. And again, if you do this one right, you should be left with just a constant for as your degree. Okay, so if you do the radian to degrees right, you should no longer have pi in your equation. So we're going to see that in examples 1 and 2. So for example 1, convert the following angles from degree to radian measure in terms of pi. Okay, so that tells you right away that all of your answers should have pi in them. Okay, so right now we have 45 degrees. We're going from degrees to radian, so we're taking what it's given us, which is 45 degrees, and multiplying it by pi over 180.
This is our degree.
Yep. So when I multiply across, I get 45 pi over 180. Now I need to see if that can be reduced. So do y'all remember how to do that in your calculator?
No, I don't remember what we're doing.
Isn't it like math or mode?
Anyone?
So you take 45, divide it by 180, and you're going to get some type of decimal. In this case, hopefully we know what 0.25 is as a fraction, but in the event that you didn't, you would press math, the number 1, and enter. And that tells you it's 1/4 as well. So, 45 over 180 is the same as 1/4,
Pi.
and it would be 1/4 pi, or you can just write pi over 4.
Can we just do 1/4 pi?
Yeah. I think you should just leave it.
Sloppy numbers.
No. Okay, let's try another one. 135 degrees. Okay, that's what we're given. So you have 135 times pi over 180. Multiply your numerators together, you get 135 pi over 180. And you're first going to see, does 135 over 180 simplify? What does it simplify to? 3/4. So you have 3 pi over 4.
3/4 pi.
Yeah, so go ahead and do C and D on your own.
Why would this say 180? Would you not multiply that?
No,
Oh, because
when you're
over
multiplying.
1.
Yes.
That's it.
So far. So far. The other stuff's easy too, it just takes practice. It also took me practice how to teach again. I'm just kidding.
Really?
Dusty, I missed you. It's like, who am I so excited to see when I get back? You make me laugh. Yes, you do.
You didn't say you missed anyone else in this class. I bet they're all offended.
It makes me laugh.
But I feel like you offended a lot of people in this class.
Especially Bella.
Bella's offended, in other words.
Hmm?
I don't want it. But I'm not going to show it.
And then I would like check in the grade book and I would still see absence for Joseph. Still not ever coming.
Wait, why does he never come?
I don't know.
What?
Okay.
Okay, but wait, what?
Why do you never come?
I wasn't gone that much this March, like.
But just like, why do you just not show up?
Did you win?
Yeah, we won state.
Well, I know that, but aren't you doing something further?
We're going to nationals next week.
Yeah, so you're gonna be gone
I'll
again.
be gone for 3 days.
Oh gosh.
Okay, but she lost the first skills check.
Well, looks like you're gonna have to redo it.
I know.
Okay, anyways. Okay, C, what'd you get?
5 pi over 4.
Very good.
5/4.
And D, what do we get?
7 pi over 4.
Sweet. Okay, now we're just gonna go the other way. Still simple. Okay, you have pi over 6. This time you're in radians because you have pi. So anytime, again, that you have pi, that means you're in radians. Okay, so pi over 6. Okay, this time we're using radian times 180 over pi. So now we're multiplying. Okay, and then right here, because you have a pi in the numerator and the denominator, you can cancel them. Not cross multiply. But if you were to multiply these across, that's 180 pi over 6 pi, and then they cancel. I just canceled them early. Okay, and then 180 over 6 is 30, and then now we're in degrees. Okay, so try B on your own.
What would you do with 5?
5 times 180. Okay, what do we get for B? 300 degrees. So you had 5 pi over 3 times 180 over pi. Your pi's canceled. 5 times 180 was 900 over 3, and you get 300 degrees. Okay. Again, whether we're in radians or degrees, these numbers represent your theta. So it represents your central angle. Okay? These are not lengths. These are measures. Okay? So, again, I'll bring it up when I show you the length so that you can see the differences. But these are measures. Alright, turn the page. department needs to build a fence along the outfield of the softball field. The outfield is an arc of a circle. What is the circumference of this circle? So if this circle were to have been whole, okay, we need to find the circumference. So how do we find circumference again?
Pi, r squared.
Not pi r squared.
2 pi r.
2 pi r. What is our radius here? 190. So if this circle were to have been whole, what would be the circumference in terms of pi?
190 times 2.
380 pi feet. Don't start forgetting your units. Remember that circumference is just like perimeter, it's just in your base unit. Okay, what is the degree measure of the central angle of this arc? Which angle is our central angle?
This one.
Wait, sorry,
A, B, C, or D? Which one's the central angle? A, okay? So it's the one that opens up to your arc length. Okay? How do we know that A is 90 degrees?
Because, I don't know.
Wait, can you repeat what you just said?
Your central angle is always the one that opens up to the arc. Very good, guys. Because it's a square, it has to be 90. Okay? So if these three angles are 90, you know your quadrilateral has to be 360, which leaves this being 90 degrees. Okay? C, the field is what fraction of the circle? How many degrees is in your total circle? 360, and how many degrees do we currently have? 90. So, simplified, what fraction of the field is this? 1/4. So this one was kind of easy to see that it was 1/4, but it's not always going to be a quarter. It could be a really small sliver. Okay? So make sure you always set up your fraction and then reduce it. So 1/4.
Does it normally give you the degree inside?
Yeah.
Central?
So for
It'll
degree,
be
we
either
always,
give it to you or it'll be marked with a right angle.
for degree we do pi over 180. We're still doing that.
Yeah, sure. Okay, so letter D, what is the length of the outfield fence? Okay, so the entire circumference is 380 pi feet, and we have 1/4 of the field.
Divided by 4.
How are we going to get the length of just the fence?
5.
So if we have the whole, and we want just the part, how are we going to get the piece?
Divided by 4.
Divide it by, or multiply, okay? So 1/4 times 380 pi is the same thing as saying 380 pi divided by 4. Okay, so what is the length of the outfield?
95
95
pi.
pi what? Feet. So we're taking a part of the whole. So part times whole. So the whole circumference of this circle would have been 380, but we currently only have 1/4. You just have to divide.
Okay.
Okay, so we just did a 4-step problem to figure out the arc length. Okay, so this is arc length. Because this was 90 degrees, okay, the measure of this arc is 90 degrees, but that is not the same thing as the arc length. Okay, so in chapter 11, remember every time your central angles opened up, if this was 90 degrees, you said that this is 90 degrees. Okay, we're no longer looking at measures, we're looking at the length. Okay, so now you actually have to use an equation, or you can do this little 4-step process every single time to figure out the actual length. So, down here it says, can you come up with a formula to find the arc length of a circle? Okay, so if you have the central angle in degrees and your radius, okay, you're going to find the arc length by taking degree over 360. Okay, so that's what we did up here, degree over 360 times the circumference, so 2 pi r. And we did that. We took the degree over 360, which is what we got as 1/4, and then we multiplied it by the circumference, which was 380 pi. So degree over 360 times circumference, and that's going to give you your arc length. Okay, so this is if it is in degrees already. Okay, so because this theta was 90 degrees, that's the formula we would use. Okay. Let's say this wasn't 90 degrees. Let's say they said that it was pi over 2. Okay, so now we're in radians because we're in terms of pi. So if your central angle is in radians, okay, you are taking radian equals theta times your radius. That should have been a lowercase r, but theta times your radius. Okay, and so for this problem up here, 90 degrees, like we established on the front page, 90 degrees was equal to pi over 2. That's why I wrote pi over 2. Okay, so you would have had pi over 2 times our radius, which was 190, and that simplifies to 95 pi. Okay, so now you have two ways of finding arc length depending on whether you're given your central angle measure in degrees or radians. Okay, so kind of a lot to take in right now, but here we are, we're about to practice. Real quick before we start practicing, do you guys remember how you name minor arcs and major arcs? Minor arcs are 2 letters and major arcs are 3 letters. Okay, so keep that in mind. Alright, so C is the center of each circle. Find the length of each darkened arc. Leave answer in terms of pi. Alright. Is our central angle in degrees or radians? Degrees, and what would that be? 90. Could you have also done it in radians? And what would that have been? Pi over 2. Okay, so 90 degrees. Okay, when we are in degrees, you take the degree over 360 and multiply it by 2 pi r. So I have degree over 360 times 2 pi r. That's what formula I'm using because I chose to do 90 degrees. So I have 90 over 360 times 2 pi, and my radius is 8. 90 over 360 is going to reduce to what? 1/4 times 2 pi 8. Okay, so when I multiply my numerator, I have 1 times 2 times 8, which is what? 16, and then I have my pi. Don't leave off your pi. And then in my denominator, I only have 4. And then how does that simplify? 4 pi. And then in this case, we have centimeters. Questions? Maddie?
So would you be like putting 2 pi 8 in a fraction basically?
Yeah, you can put it over 1.
Yeah, okay.
And then you're multiplying numerator times denominator. Any other questions on A?
I don't know where, I just don't know where you got that.
That's the formula.
It doesn't have to do anything with that?
No. So this was arc measures, and now we're looking at arc length. Alright. C is the center of each circle, blah, 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 back to it. Okay, we're looking for the darkened arc. Okay, so what is the central angle for the darkened arc? 240. 240, why 240, Money?
Because I did 360 minus 120.
360 minus 120 to get this angle here that opens up to this arc. Okay, so again, we're in degrees. So I'm going to have theta over 360 times 2 pi r. Okay, my angle now is 240 over 360 times 2 pi, my radius is 8. So if I want to put it over 1, I can. So you multiply all your constants in your numerator together and then attach pi at the end. Don't forget to put pi in there. And then 360. And then make sure you simplify.
Wait,
Or you can simplify first.
to multiply top and top. And then the
Yeah. Or you can simplify first. 240 over 360 simplifies to what?
2/3.
2/3 times 2 pi 8 over 1.
Can you simplify that too?
Not yet.
Wait, so are we allowed to leave it in a fraction, like the final answer?
If it's simplified.
Wait,
But this isn't simplified yet.
16 pi.
Okay, so 16 pi. More than that.
32.
32, because you have 2 times 2 is 4 times 8. 32 pi. And then your denominator is 3. And in this case, Gabby, no, it can't be simplified, so you would leave it as 32 pi over 3. Yes, Maddie?
Never mind, I did my math wrong.
Okay. Okay, questions on problem 1, A and B? Yes, Maddie?
I forgot to send you.
Oh, good catch. Make sure you have your units. I'm back. Better than ever. Just kidding. Alright. Now we're going to look at, so this was using degrees, okay? Like I said, you may have problems where you have radians. Okay, so we're going to look at that in question number, whatever this is, 2. Alright, my circumference of a circle is 400 pi. And it wants to know the diameter, the radius, and the length of an arc of 240 degrees given that circumference. Given a circumference, how would I figure out the radius?
Divided by 3, 4.
Okay, so circumference, what's our formula for finding circumference?
2 pi r.
2 pi r, so I'm going to substitute that in, equals 400 pi. And so to get r by itself, what do I have to do? Divide both sides by 2 pi. Okay, so since you have 2 pi on top and bottom, those cancel, so you're left with just r. Over here you have pi and pi, so those cancel. And what's 400 over 2? 200. So my radius is 200, and just units, because...
Divide by 2.
No,
Divide by 2.
you divide by 2 pi.
No, I mean, you multiply by 2.
For this side? Yeah, on this side you're doing 400 divided by 2.
Like it's
But you had to divide both sides by 2 pi. Because you might have problems down the stretch, never probably, but like later on in life, where this might have just been 400 and not 400 pi, and then it wouldn't have canceled. You'd have actually had to divide by 2 times 3.14, blah, 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 blah. Okay, diameter is what?
400.
400. Alright, so now it wants us to do arc length. Okay, it says find the length of an arc of 240 degrees. So do we have degrees or radians? Degrees, so what formula are we going to use? Pi over, or not pi, theta over
What is that called? Beta?
theta.
Theta. Theta.
It's a Greek letter.
Theta.
So theta over 360 times what? 2 pi r. Okay, we're going to substitute in. Okay, our degree is 240. They gave us that. Over 360. We know that our circumference is 400 because they already gave us that. 400 pi, sorry. Okay, 240 over 360 simplifies to what? 2/3 times 400 pi. So what are you left with as your arc length?
803.
800 pi over 3.
Is that the answer?
Yep. Not bad, right? Okay, bad news. these 4 things that we just went over, the conversion between radians to degrees, degrees to radians, and these 2 arc length formulas are not on your formula sheet. So you have to memorize them. But they're easy. Once you do them a few times, you pick up on it. Okay, example 3, find the length of EF below. This should have a little guy up above it. Alright, EF, are we looking at the larger portion or the smaller portion? Smaller, okay, your minor arc.
Wait, what? We're always looking at the small one.
Yes, unless it has 3 letters. If it has 3 letters, that's the only way you can name a major arc. Alright, so are we given radians or degrees? Degrees, so what formula are we using? Theta over 360 times 2 pi r. Very good. Okay, substitute in. So we have 120 over 360 equals 2 pi times 6. Oh, not equals, times. 120 over 360 simplifies to what? 1/3. And then you have 2 pi 6. Okay, so multiply top times top, bottom times bottom, and you get 12 pi over 3, which simplifies to what? 4 pi.
Whoa, that's,
Units.
wait, how'd you get 12?
2
Oh.
times 6. There you go. And then 12 divided by 3. Alright. Moving right along. Sometimes you might have an extra step. Example 4, find the length of LM below. So again, are we looking at the large LM or the small?
Small.
Small, so we're looking at this guy. Do we know the central angle for that guy? 60. How do we know it's 60? 360 minus this 300 degrees. So this is 300 degrees. Over here would be 60 degrees. And then you know that your central angle opens up to your arc measure at the same value. Okay, so that's 60 degrees as well. Okay, so again, are we in radians or degrees? Degrees. So you have theta over 360 times 2 pi r. And I want you to do this on your own. Figure out the length of LM.
Is the 3 the radius?
The 3 is the radius.
Do you multiply these first and then multiply by that, or do you?
I would simplify this first. It's just easier to multiply smaller numbers together than big numbers. Okay, so hopefully you had 60 over 360 times 2 pi radius of 3. 60 over 360 reduces to 1/6 times 2 pi over 3. 2 pi times 3. And then you should have got 6 pi over 6, which reduces to 1 pi. So you just have pi units.
And put a 1.
No. Okay, so that's looking at arc length given degrees. Arc length given degrees. Obviously, sometimes you're going to be given radians, and that's examples 5 and 6. What color haven't you used? Brown, this poop one?
Ew. Wanna catch?
Is this arc giving radians?
Yes. So this is given radians. So what is our rule if we're in radians? Okay, very good. So you're going to have theta times your radius.
Because.
Sorry.
Oh, dang it. Oh, this is me. You can open it.
Okay. So this is where last class kind of got confused with the difference between arc measure and arc length. Okay. Are we looking at the big EF or the little EF?
Little.
Little. Wee. Alright. Do we have the central angle for that little EF?
No.
No. How are we going to figure out the central angle of EF?
Find the arc.
What?
How are we going to figure out what this guy is?
Subtract that from 360.
Okay. Not 360 because we're no longer in degrees, but what do we know that 360 is equivalent to in radians? 2 pi. So remember on that front page, okay, we talked about the entire circle is 2 pi, okay, and then half your circle is just pi. So 360 degrees equals 2 pi, 180 degrees equals pi. Okay, so this is 2 pi over 3. How am I going to figure out what this is?
2 pi minus 2 pi divided by 3.
2 pi minus 2 pi over 3. And that's how I'm going to figure out the measure of EF.
Then you.
Okay.
Okay.
So remember that you can't just cross these out. This is not the same thing as multiplication. What do you have to find before you can subtract?
Common denominator.
Common denominator. So if this is 3, okay, how am I going to convert this so it has a denominator of 3?
2, 6, and 3.
Very good. So multiply top and bottom by 3, and you're going to get 6 pi over 3
So you.
minus 2 pi over 3. So you just multiply top and bottom by 3. If this was over a 1.
Okay. So you move the 3 right here.
You're not moving, you're multiplying because you want to figure out how to get this to have a denominator of 3. So 2 pi, 6 pi over 3 reduces to 2 pi. And that way they both have 3 in the denominator and you can subtract.
So how can I draw that to remember that? Like, how do you draw? Say multiply by 2.
I mean, I guess you could do top and bottom by 3.
Oh, yeah, that's.
Alright, so 6 pi minus 2 pi is going to give you what? 4 pi over 3. Okay, remember that your 3's do not cancel. Your denominator stays the same. Okay, so now we know that the measure of theta is 4 pi over 3. Okay, which means that this measure is 4 pi over 3. Because again, your central angle always is congruent to the arc length that it intersects. Okay, so this is kind of where they got confused last class. They're like, well, don't we already know now that EF is 4 pi over 3? Okay, remember that 4 pi over 3 represents the measure, okay, or that angle. Okay, it does not represent the length. Okay, so now we're going to use our rule to figure out what the actual length is. Okay, so for example 5, theta is 4 pi over 3, and your radius is what? 6. Okay, so multiply top times top, bottom times bottom, you get 24 pi over 3, and that simplifies to what? 8 pi units. Okay, try number 6 on your own. It's the same idea. Try number 6 on your own. You're looking for LM. Gusty, what's up? How are you? You're so quiet. Oh, focus. That sub knocks some focus into you? Yeah.
Do you want us to leave it in a fraction, or do you want us to convert it to decimal?
For this test, it'll all be fractions. Unless it says to round to the nearest thousandth, leave it in fractions.
Is that it? For the, not done, but like.
Okay, yeah.
This one's broken.
Some of them are like coming unscrewed. I think it's because as I write.
Watch. It like doesn't go up.
Yeah, it's like.
You have to like press it.
Alright, because we're talking, I'm guessing we're finished. Okay, how did you figure out what the measure was over here?
2 pi.
2 pi minus 5 pi over 4. Once you got your common denominator, you should have had 8 pi over 4 minus 5 pi over 4. So what did you get as your central angle?
3 pi over 4.
3 pi over 4. Okay, so then you take your central angle times your radius. Okay, so you have 3 pi over 4 times your radius, which is 3. Or 3 over 1, however you want to say it. And so what did you get as the length of LM?
9 pi over 4.
Units. Very good. Alright, we are going to take the skills check in 15 minutes. Okay, I want to run through some practice problems that are going to look similar to your skills check. If you want to run through them with me, you're welcome to, or if you just want to work on your homework, you can do that as well. But if you just want to get scratch paper out or just write in the blank space on your notes or whatever you want to do, there's scratch paper up there underneath the podium.
Can I figure everything?
Can I go to the restroom?
Yep. I just want to kind of practice some problems with you guys. And it'll help you start memorizing those formulas. Alright, so those of you that are working with me,
I just took it with these are different, like, when we would use this.
I'll show you. I'll do it right now. Okay, first 3 problems, conversions.
Or that.
Okay, so your conversions. First one you're converting is pi over 4. So if you're currently in radians, obviously you're going to convert to degrees. If you're not in radians, you'll convert degrees to radians. Okay, so you're going to do pi over 4. You're going to do 54 degrees. And you're going to do 2 pi over 3. Okay, so this is when you're using that first part of the notes to figure out how you can calculate radian measures or degree measures. 2 is 54 degrees. Yes, Amania?
Are we going to be given the formula?
You will not have the formulas on your skills check. Okay, so if you're currently in radians.
I'm just trying to remember. I know it's either 180 divided by.
So if you're in radians, you're going to take radians times 180 over pi because you want your pi's to cancel. So if pi is in your numerator, you're going to be multiplying by 180 over pi. Because you want them to be opposite of each other so they cancel. And so now they'll cancel, and then you'll be able to figure out.
180 divided by 4.
Very good. 45 degrees. Yep.
This is 180. This is pi over 180.
Pi over 180, yeah. So basically you want your pi's to always be across from each other, and your diagonal, and your numbers to always be diagonal.
And why would we do conversion? Like, how would we know to use this and not that?
So this is arc length, and this is angle. Central angle.
Oh, because this gets this unit dot measure, and this gets this unit. Over 1.
Take about another minute. what did you get as your degrees? 45. Very good. Number 2, what did you get as your radians? 3 pi over 10.
Is that degrees too?
And no. When it's 3 pi over 10, those are in radians. So if you wanted to write your units, you would just write rad. And number 3, what did you get for your degrees? 120 degrees. Any questions on 1, 2, or 3? So again, these are measures, okay? Measures. Arc lengths are always going to have units. Measures are going to be in degrees and radians. Guys.
Wait, these are degrees.
The numbers are always degrees. The ones with pi are always radians. Alright, next one.
So these are measures and these are degrees?
Measures are degrees. Degrees and radians are measures.
Okay. And then these are degrees?
These are arc lengths. These are where your units are. Okay. This is 45 degrees. And your radius is 4 inches. Oh, sorry. Okay. I want you to find the radian. So I want you to do a conversion and find what 45 degrees is in radians. And then I also want you to find the arc length. – 45 degrees is the angle, and 4 inches is the radius. So I want you first to practice that conversion, convert 45 degrees, and then I want you to find the arc length. If you're working on the homework, that's fine, but just please be quiet until I'm done talking with everyone else.
Could you say pi over 4?
Mm-hmm.
Wait, what are we trying to do? Are we trying to find the radius?
You're finding the small part. Radians is, remember, you take your degree and you multiply it by pi over 180. Alright, what did you guys get in radians? Pi over 4. Listen. Because you will see that on your skills check. Please listen. Alright. Once you have radians, okay, at this point now you have it in radians and in degrees. So how you choose to go about solving arc length is completely up to you. Okay, you can use the degree formula or you can use the radian formula because now you have both. So if you're using the radian formula, you're taking pi over 4 and you're multiplying it times your radius, okay, and you just get pi. If you're using your degree formula, you're doing 45 over 360 times 2 pi 4. Okay, 45 over 360 simplifies to 1/8. 2 pi times 4 is 8 pi. And again, you're left with just pi. So no matter which method you use, you're going to get the same answer if you do it right. Okay, but this was just a two-step problem. This is to practice converting and then also knowing how to solve arc length. Okay, so I think it's easier, obviously, to go from radians times your radius to figure out arc length, but degree is not necessarily hard. It's just more steps.
Is it the same as you have the degrees one? You just take that and divide.
Yeah, I'm about to do one like that. Okay, so your arc length here was pi units. Okay, next one.
I borrow one of those.
Okay, next one. Yeah. Thanks, man. It's pretty cool. Alright. My circle's kind of ugly, but it's fine. So I want degrees, and I want arc length.
Is it saying what pi over 5?
Pi over 5 is this, which is equivalent to what?
Central
The
angle.
central angle. So pi over 5, and the radius is 5 feet.
So wouldn't that just be the same?
That pi over 5
It's in radians. Anything that's in terms of pi is radians.
So you can just multiply that by the radius? Or the degree?
So if you're going to use degree, you have to use the degree formula. If you're going to use radian, you use the radian.
Okay. No, but you did this weird way to find that, right? I don't know. Never mind. You said there's another way to find that.
Yeah, so you can use the degree, which is 36 over 360 times 2 pi r. Or you can use radian, which is pi over 5 times radius.
Oh, okay.
What does the pi over 5
The measure of that arc.
Well, aren't we already given the arc length?
The measure of the arc is different than the arc length. Remember I was telling you guys that? Arc length and arc measure are two different things.
So we can use either of these equations, that or the degree for
Correct. You just
finding
have to make
the
sure
arc.
you do the right thing. Like this is in radians, so you can't do 36 times 5. You would have to do pi over 5 times 5.
But we couldn't do pi over 5 times 5. Yeah.
You can do pi over 5 times 5, you just can't do 36 times 5. You just have to make sure you're substituting and using the right thing.
Okay, that's why you told me I could do that. Okay. But I'm just gonna do it but we can both do
You can do either. You'll get the
radians
same
or
answer.
degrees.
Alright, what did you get for the degree? 36 degrees. Okay, at this point, you can use the degree formula, which is the theta over 360 times 2 pi r, or you can use the radian formula because you have the radians to begin with, which is just theta times radius. Okay, either way, what do you get as your arc length? Pi units. I didn't mean to do that. Make them the same.
How does she find the degree?
So you take pi over 5 times 180 over pi. That's that conversion piece. No, not yet.
So this pi over 5 is this part, right? The outside part.
Right.
And then I got 36 degrees for the outside part.
Correct.
And then isn't this the arc length? Which arc length are we supposed to find?
You're finding the minor one. I
Wouldn't that
scribbled
also
on
be
it.
36 then?
Okay, have a seat. I'm going to explain it again. Okay, just because two people have asked this back to back, remember, your arc length and your arc measures are two different things. Your arc length should always have units attached to it, inches, centimeters, whatever. It should be a part of your circumference. Your arc measure is either in degrees or radians. Okay, so that first part that we did the conversions, that was to find arc measures. Okay, because I know that this is 36 degrees, I'm not finished. Okay, 36 degrees represents a measure. I have to find the length. Does that make sense? Okay. I'll do one more, put one more up here, and then we're going to take the skills check. You have 2 minutes to do this because we got to get going on the skills check. So theta is 2 pi over 3, and your radius is 6 inches. Theta is 2 pi over 3, and your radius is 6 inches. So you're going to find degrees again, and arc length. How you find arc length is up to you. You can use radians or degrees. Just make sure you substitute in properly. So your central angle is 2 pi over 3, and your radius is 6 inches.
So you can always take this arc right here and multiply by the radius all the time to find the arc length.
As long as you're given radians.
And radians is one concept. If not, you have to do the
Like if that would have been 120 degrees, you can't do 120
this way.
Yeah.
So you do, so if this was 120, you do 120 divided by 360 times 2 pi r. Do you want me to, can I stay here or can I?
Alright, 2 pi over 3 radians is equal to how many degrees? 120 degrees. Okay, what is your arc length? 4 pi units. Very good. Okay, clear up your desk. Because you take 2 pi over 3 times 6, and that's 12 pi over 3. Simplifies to 4 pi. That's what your theta is. So since we're in radians, radians is just theta times radius. And theta is 2 pi over 3, and your radius is 6. If you did it the other way, using degrees, I'm going to write it down here. You would have 120 over 360 times 2 pi times 6. 120 over 360 is 1/3. So now you have 1/3 times 2 pi times 6 is 12 pi. And again, you have 12 pi over 3, which is 4 pi. So either way you do it, you get the same answer. It's up to you how you want to do it.